Welcome back. Our previous video went through some numerical simulations to illustrate the central limit theorem and the Fisher-Tippett-Gnedenko theorem. And in today's video, I wanted to talk a little bit more about the Fréchet distribution and some of its special properties and how it can be useful in empirical economics research. And this is setting the table for the next video, which will go through the Eaton-Kortum trade model, which has the Fréchet distribution front and center. And as a reminder, the Fréchet distribution is the type 2 extreme value distribution that arises when the parent distribution is heavy-tailed. The CDF is this equation, and there are 3 parameters that this distribution has instead of 1 or 2. It's got a tail index parameter, which is a shape parameter alpha, and then it also has the typical location and scale parameters, which are mu and beta in this nomenclature. And I wanted to point out the similarity with the type 1 extreme value distribution, or the Gumbel distribution. And you can see in this blue highlighted section, we have the Fréchet distribution function without the exponentiated negative alpha. And that whole thing is exponentiated with the negative to get the Gumbel. So what this ends up meaning is that if x has a Fréchet distribution, then the log of x is going to have a Gumbel type distribution. As you can see, it doesn't exactly add up quite as nicely, but more or less you can think of Gumbel as being log Fréchet. Another useful property of the Fréchet distribution, which will be useful in some economic models, is that it has a power law in its upper tail. And this contrasts with a thin-tailed distribution, which has an exponential decay in the upper tail. So because there's a power law upper tail that's governed by the shape parameter alpha, that's going to result in a lot more heaviness in the tails, and that can be really important for modeling some economic phenomena. Another property of the Fréchet distribution is called scale invariance, which just means if I multiply the Fréchet distribution by a constant, it's not going to affect the distribution. I'm going to get the same distribution back with only a slight modification required. And the above properties imply that the maximum of a Fréchet distribution is distributed Fréchet as well, with a slight change in normalization. And this is referred to as the max stable property. And this is going to prove to be very convenient for achieving closed form formulas in some economic models. So why would we want to use a distribution like this in economics? Well, it's going to be really useful in a situation where relative comparisons matter more than absolute levels. So this is going to arise in any kind of ranked data. And it turns out that there's a lot of situations where comparing the top performer to the 10th best performer is going to be all that we need to think about to model the phenomenon, as opposed to thinking about how much money the top person has compared to the 10th highest person. That's what we mean by comparisons mattering more than absolute levels. It's about the relative rank. It's not about the particular size. And you also see this in distributions of city sizes, where maybe the underlying distribution is Pareto within a country, but then if we think about the distribution of the biggest cities in every country across the world, then that might have a Fréchet distribution because it's the distribution of the maxes. And Fréchet distributions arise when there's extreme heterogeneity in the model, and these would typically happen in situations where there are winner-take-all dynamics, where there's superstar effects. And what we mean by superstar is the top 1% are vastly different from the median, where there's a long right tail, which means that there are observations with really high levels that are rare, but much more frequent than in a thin-tailed distribution. And these contrast with the Gumbel distribution, which is thin-tailed and has more moderate heterogeneity. And hopefully you can kind of see that if Gumbel is log Fréchet, then Fréchet is going to be exponentiated Gumbel. And so any kind of differences in the Gumbel would be magnified when we take the exponential of those differences, if we think in terms of levels. So hopefully that provides a little bit of intuition, but if it doesn't, Don't worry about it. How are we applying the Fréchet distribution in economics and finance? Basically, there are a lot of situations where the underlying distribution has fat tails like a Pareto or a Cauchy. And then if we want to think about maximum over those distributions, then that's when Fréchet would come in. And the model we'll talk about extensively in the next video, the Eaton-Kortum model of trade, leverages this idea when thinking about how likely countries are to trade with each other, and how that might be influenced by underlying productivity differences. There's also a very famous paper by Melitz that talks about firm productivity. And there's also a well-known literature about top incomes where we have several, we have so many billionaires in the country, but then the typical person only makes $50,000. And if we're thinking about corporate finance or public finance, there's tail risk in financial losses and in natural disaster damages, and this can be appropriately modeled as Fréchet. So that is a little bit about the Fréchet distribution, and in particular, the properties of the Fréchet distribution that are useful for making tractable economic models of certain phenomena. And we'll put this into action in our next video, which will wrap up the mini-series, where we walk through the Eaton-Kortum model, which is a workhorse model in international trade. And this model leverages the Fréchet distribution in order to get results that are both empirically tractable and theoretically founded. So I hope you'll join me for that last video.